Question number 1. A rail car of mass 5m rests on a smooth horizontal track. An engine of mass 3m moving at 8 meters per second collides and couples with rail car. The speed of the engine after the impact is. There is a collision. Therefore, we have to consider, we have to use conservation of linear momentum. 5m initial velocity 0. I will consider 5m mass, initial velocity 0. 3m initial velocity 8 meters per second. It is the before collision situation. And then colliding and couples. It means we have to consider these two objects are acting as a single object. Then mass is 8m. We have to find the final velocity. Then we can use conservation of linear momentum in this direction. Mass into velocity 3m into 8 plus 5m into 0. Sum of momentum before the collision should be equal to momentum after the collision 8m into v. We can cancel out m terms. 3 into 8 24 divided by 8 3 meters per second. Then answer is 2 for the question number 1. Then question number 2. An astronaut of mass m is launched from the surface of the moon in a spacecraft having an initial velocity, initial vertical acceleration 5g, where g is the acceleration of free fall in moon. The vertical reaction of the spacecraft on the astronaut is, initial acceleration is 5g. It is acceleration. Then we can use F equals ma to the astronaut in upward direction. We have to find the force. Force is the reaction due to this surface. We have to find it. Reaction. Mass m, acceleration 5g. But there is a weight in this direction. It should be mg. Reaction in upward direction. Therefore, we can consider resultant r minus mg. Resultant force is r minus mg. Then we can get r should be 5mg plus mg, 6mg. Then answer is 5 for the question number 2. Then question number 3. When a mass is suspended vertically by a light spring from the ceiling of a stationary lift, the extension of the spring is found to be x0. If the lift is then set in motion of vertically downward direction, so that velocity varies with time according to the graph shown in the figure. Variation of the extension of the spring with time is best represented by. I will consider the object hangs by a spring. It is like this. There is an initial extension due to weight of the object. The lift is moving in downward direction, and first part is an acceleration. We can identify velocity time graph is like this. It has a constant gradient. It means constant acceleration. Gradient of velocity time graph is representing acceleration. Constant acceleration in downward direction. Then we can get For the initial situation, mg should be equals to kx naught. Now, there is an acceleration in downward direction. When accelerating the system in downward direction, there is a resultant force on this object in downward direction. Therefore, mg is constant. We have to consider this extension should be less than x naught. Then extension should be less than x naught, and it is a constant value. For the second situation, velocity time graph is this one. It is a horizontal line. It means it has a constant velocity. If the system is moving with a constant velocity or it is at rest, there is no resultant force. Therefore, kx naught equals mg. We can consider extension should be x naught. Then for the third situation, there is a deceleration in downward direction. It means we can consider it as an acceleration in upward direction. If there is an acceleration in upward direction, this force should be greater than this one. Therefore, extension should be greater than x naught. The graph should be like this. Then we can consider less than x naught, equal x naught, and greater than x naught. But in given graph, x naught values are not given in correct position. But we can get the shape. Then answer should be 1 for the question number 3. Then question number 4. An object of mass moving with speed v along the x-axis suddenly breaks into two identical pieces. If one of broken pieces moves parallel to the y-axis and along its positive direction with speed v, which of the following diagrams best indicate the direction of motion of other pieces? An object is object of mass m moving with v speed along x-axis. Therefore, there is a momentum in this direction for the first situation. After the explosion, this part is moving in this direction. Before the collision, there is no momentum in vertical direction. Therefore, after the collision, the momentum in vertical direction should be 0. Therefore, there is a velocity in downward direction for this piece. We have to find the resultant velocity for this piece. And initially, there is a velocity in horizontal direction. Therefore, there is a momentum in horizontal direction. We have to get there is a momentum in horizontal direction for this piece because of this one is moving in y direction. Then we have to consider the resultant. It should be like 2, 3 or 4. What they have given, this velocity is v, this velocity is also v, then this velocity also should be v, and this velocity is greater than this one. I will consider conservation of linear momentum in this direction to explain this. If the mass is 2m before the collision, 2mv is the momentum in this direction. For this part, mass m, we have to find v dash velocity. Now you can get v dash velocity is 2v. It is greater than this one. Therefore, resultant should be near to x-axis. Then answer should be 2 for the question number 4. Question number 5. As shown in the figure, a child is holding a strong magnet in front of an iron trolley placed on a smooth track. Which of the following statement made about the trolley is true? It is moving with a uniform speed. It moves with a uniform acceleration. It accelerates initially and moves with a uniform speed. On weaving, stars will appear. No, it is a false statement. There is a problem with given statement. I will explain only the answer. When considering trolley, there is a magnet like this. There are two magnetic forces in the system. There is a force on magnet due to this iron trolley, and there is another force equal and opposite to the iron trolley. When considering total system, there is no an external unbalanced force. Therefore, it should be at rest or moving with a constant velocity because of acceleration should be 0. But they have not given the that there is a movement. Therefore, the system should be at rest. Write the answer as at rest. There is a problem with given statement. Then question number 6. An object of mass 5 kg is subjected to a resultant force F, which varies the time t as shown in the graph. The momentum gained by the object in 10 seconds is. We know that change of momentum change is, according to Newton's second law, external unbalanced force is the rate of change of momentum. Change of momentum divided by time. Now we can consider change of momentum is Ft, force into time. Force into time means the product between y and x physical quantities given in the graph. Therefore, we have to find the area of the graph when getting the physical quantity which is equal to the product of y and x axis. We have to get the area of the graph. Now, there is the trapezium. Then area is half into sum of parallel sides. 10 plus 6 into perpendicular height 5. 16 divided by 2, 8 into 2, 8, 8 into 5, 40. 40 Newton second. Then answer is 3 for the question number 6. Then question number 7. A mass of 0.4 kg is suspended from a light spring as shown in the figure. The second mass 0.2 kg is suspended from the first by a thread. When the system is equilibrium, the thread is burnt. The initial acceleration of the 0.4 kg mass will be. There is a problem with given diagram. It should be like this. This weight is 0.4 kg and there is a thread and this weight should be 0.2 kg. The thread is burnt. When considering this situation, it is in an equilibrium. Therefore, force due to spring should be equal to tension of the thread plus this weight. Weight is 4 Newton. Then we can write for the first situation kx equals t plus 4. Equilibrium. And when the when this thread is burned, tension should be 0. Therefore, change of force equals to tension. But we know that for the first situation, when considering this object, tension should be equals to T Newton. For this object, upward force tension should be equals to downward force 2 Newton. Therefore, when the thread is burning, the upward resultant force on this object is equal to the tension, it is 2 Newton. Then we can get F equals ma. 2 Newton is the external unbalanced force, should be equal to mass 0.4 into A. We have to find the acceleration. Acceleration is 20 divided by 4. 5 meters per square second. Then also should be 2 for the question number 7. Then question number 8. The velocity time curve of a particular particle of mass m moving along a straight line is shown in the figure. There are 3 statements. We have to consider correct statement. Statement A. The particle returns to the motion. Yes, when considering this area, it is equal to this area. This area is representing, we know that area of velocity time graph is representing displacement. Then for the displacement for the plus direction equals to displacement for the minus direction. Then it returns to the initial position. A is correct. Acceleration of the particle does not change direction during the motion. Yes, it is also correct. This gradient and this gradient are plus. Gradient of velocity time graph is representing acceleration. Then B also correct. C, at t equals t naught. T naught means this time, this one. The impulse acting on the particle is infinite. Impulse. We can get impulse is change of momentum. Change of momentum is initial momentum mv naught minus, final momentum. I will consider final momentum first. Minus mv naught mass into this velocity. We have to subtract initial momentum. It is in upward direction, therefore it is minus, it is plus mv. Now we can simplify it. 2 mv naught minus 2 mv naught, minus means considered direction. Therefore, it is not infinite. Then C is incorrect. Only A and B are true. Fourth one is the correct answer for question number 8. Then question number 9. When two objects A and B collide with each other, in which of the action FA and reaction F are forces correctly marked on object? We know that when considering Newton's third law, there is an equal and opposite reaction for every action. Then we have to consider there are properties of action and reaction. First one is equal in magnitude. Second one is opposite direction. Third one is acting in the same straight line, same action line. Fourth one is the important thing, acting on two bodies, acting on two objects. Then when colliding these two objects, there is a reaction in this direction due to this object. Or this on this object there is a reaction due to this one, and on this object there is a reaction due to this one. Then correct diagram is C for the question number 9. Then question number 10. S is a light spin compressed between two masses, and masses are held together by a string. Held together by a string is cut. 1 kilogram mass of move off with velocity 20 meters per second, then 10 kilogram mass will move with the velocity. We have to find the velocity of 10 kilogram mass. For the first situation and second situation, there is no an external unbalanced force on the system. When the string is cut, there is a force due to the spin on this mass and equal force on this mass. Therefore, we can consider these two forces are cancelling out, and there is no an external unbalanced force on system. Therefore, momentum should be conserved. We can use conservation of linear momentum. Then initial momentum is 0. There is no velocity for the system. At the final situation, they have given 1 kilogram weight is moving with a velocity 20 meters per second. Then, if we are considering velocity of this object as v, it should be equal to minus 10 into v. Minus means moving direction is opposite, therefore magnitude of linear momentum is 10v, but in opposite direction. Therefore, we have to use minus. Then we can subject v term. V value is 20 divided by 10, 2 meters per second. It is the final velocity. And then answer is 3 for the question number 10. Or we can use another method. We know that the force on this object due to spin equals to force on this object due to spin, and forces are in opposite direction, and we can get the velocity should be in this direction, and velocity should be calculated by using conservation of linear momentum. We can't use S equals ma for object because of there is no an acceleration given in the question.